Hello, and welcome to the second episode of Me at Work at Plain Space Design. In order to keep up with the rate at which things happen here at Plain Space Design, the rate at which ideas are created, we're going to have to change the format of this program because things happen here really fast. New ideas come often, sometimes 5 or 6 a week. And if we continue to try to make these slick, polished presentations like the last one, we will not be able to keep up. So I'm going to try something different this time. Last week, we said some things about numerical errors in Excel. Just want to let you know that it was not my intent to bias you against Excel, the program itself. I realized that it might not have been the Excel program that was generating the error. Could have been possibly the numerical processor in my notebook computer, or the way that I laid the equation out may have been inefficient. So we cannot eliminate those as possibilities. So the jury is still out on what was the actual cause, but we know something was going wrong, and we fixed it. Second, when I was describing the history of this program last week, the history of this project, I didn't mention how I had attempted to solve this problem during those times because I didn't remember, but it came back to me through some serious meditative recall that the way I approached it when I first tried to solve this problem was I wanted to find a combination of the perimeter or circumference formulas for the circles. 2 pi a for the major circle and 2 pi b for the minor circle. To find some combination of those circumference formulas that would give the circumference of the ellipse or perimeter of the ellipse. Really, that approach gave me something to think about it. It gave me some really encouraging results, but I just could not remember it, so I didn't start out that way this time. Today we're going to start working on evaluating what I kept in my notebook about this problem, and that's going to be a chore and experience that you definitely need some practice with if you're going to continue with this, because my notebooks are really challenging. So starting at the top here, I was looking at the fact that I had this table of numbers, and that the best thing that I could do with these numbers was to generate some difference tables. There were major circles, minor circles with X's and Y's. You can find the difference between the two circles, the numbers that came from the circles, difference between the X column and the Y column, or the difference between the major circle column and the Y column, difference between the minor circle column and the Y column. So there are many difference tables that we could generate, and often difference tables reveal patterns that are useful in evaluating things. Oftentimes, ideas jump right out at you from difference tables. Then next year, I decided to lay out my study for the two circles to create an ellipse here in the notes of what I could do next. Since I had x squared plus y squared over a squared and x squared plus y squared over b squared numbers, I figured that I could take two rows, and from these two rows create a system of equations that I could use to try to find some useful factors, and then thereby capture a means of evaluating the perimeter of the ellipse. So I set up the equation m times x sub 1 plus n times y sub 1 equals the formula for the major circle Then the other equation, m times x sub 2 plus n times y sub 2 equals the minor circle formula. So that's the system of two equations and the two unknowns, m and n. And all the other values would be known. And I actually did solve this equation and got some numbers, and I did not understand what those numbers meant. So it was nothing really useful to me because I could not figure out what to do with it. So moving right along, I went to the next phase of thought, and I figured out, well, what do I really want to do explicitly? I want to find a function of the two circles that equals the ellipse. So I labeled the major circle A, the minor circle B, and the ellipse C, and explicitly wrote f of A plus B equals C, the function of A plus B equals C. Then I solved each of these equations as f of x. Y sub A equals f of x, y sub B equals f of x, and y sub C equals f of x. So they were all based upon the same dependent variable and independent variable. Same dependent variable name y with different subscripts, and the same independent variable x. I thought now I can make a system of equations that really might give me something. So I wrote m times y sub a plus n times y sub b equals y sub c. And if I evaluated this equations at two different points, I would have a system of equations that I could solve for m and n. And I just laid that out as a sketch. I didn't actually do uh, that analysis. And also I had another sketch here, y sub c equals y sub a minus h of x times y sub b. And in this I said I could find the formula for the ellipse by modifying the formula for the major circle with a scale factor based upon x times the formula of the minor circle. So I would scale the minor circle and subtract it from the major circle and get the ellipse. Didn't do that either, but I did write it down, so it's something I could do in the future, or maybe you might want to try it, I don't know. And then the next thing I did, and I kind of developed this right here in the notebook, was to find a tangent line of the major circle y sub a, evaluated at a, and the tangent line to the minor circle y sub b evaluated at y equals b. X equals a and y equals b. I wanted to find the point D where these two tangent lines intersected. And in that direction, I took the first derivative of both uh, circles, equations, y sub a and y sub b. But also by inspection, I could see that when I drew the tangent lines to those circles, that they intersected by reason at the point x equals a, y equals b, the coordinate pair. After that, I set the two slopes to be equal and opposite to each other, the two equations, and so that if I were to add the two derivatives and set them equal to 0, that would be saying the same thing, that the slopes are equal and opposite. And when I evaluated that through, worked that through some math, I came to the solution A equals B. And so that would say pretty much that this would only work if the major and minor axis was of the same length, or in other words, with a circle. And so it's time to move on to bigger and better things. So the last thing that I did on this set of notes was to list some work that I had done with the line through the origin that had the slope y, had the slope b over a, and I found where that line would intersect the ellipse, x squared over a squared plus y squared over b squared equals 1. And I discovered that that intersection of points would be x equals a over the square root of 2 and y equals b over the square root of 2. And it appears that this is something that might be true for every ellipse. I mean, if you find something that's true for a whole family of curves, then you found something useful. That really was a good ending and something that I could really sink my teeth into. We all could. And if you want to help, you can also evaluate whether that is true, whether this is going to be true for every ellipse. Tell me what you think. And in the interest of keeping things short and sweet, as I promised I would do, or try to do, we'll say that this is a wrap.